My name is Ramesh. I'm from Transunion. Today I'll be talking about how Transunion leverages Opensearch to deliver AI-driven cloud-native services, right? And how we have adopted Agentic Microservice mesh to deliver various of our products, right? A little bit about Transunion. Transunion is a global information and insights organization. So we deliver both credit and non-credit products all across the globe. Especially my group, I'm responsible for the communication solutions enterprise products. And we have deployed our products across multiple countries and regions and successfully running it, leveraging various open source technologies and continue to evolve and adapt with the latest evolutions. All right, with that, we'll go a little bit deeper. Now, why do we need to leverage all these elements of AI-driven cloud-native microservices, right? As we all know, there are various architectural paradigms when it comes to microservice architectures, leveraging API gateways, service registries, or leveraging the service mesh architecture. And it's a decision that needs to be made based on how the product is deployed, the kind of customers, how it needs to scale, and the number of microservices or nanoservices that need to be managed as a whole, right? Now, what has changed is that cloud native is morphing into AI native as we adopt evolving AI technologies and open source. And Opensearch has made it much, much more easier, and we'll see how. Right? Secondly, going from simple automation and workflows, the evolution is leading us towards agentic microservice mesh, right? And same principles architecturally also apply here. We've always known about single responsibilities, best practices. Same things apply even for agents, right? Because we need to scale this. It's not a one-time thing. They need to be up and running. They need to be observant. Essentially, you're trusting your agentic AI-based service mesh to do the work for you, right? Thirdly, we've always been focused on monitoring and ensuring uptime and SLAs. Now it's going beyond. It's not just monitoring, auto-actioning, right? And that's where self-healing is becoming a buzzword more and more, leveraging the newly available AI-driven methodologies, right? And what exactly constitutes the AI-driven cloud-native application in a service mesh architecture? Think about it, right? We've always had exhaust from our applications, logs, metrics, traces, whatnot, system-level metrics, application level, and so forth. We call this the operational exhaust. That is one part. Secondly, there could also be the business intelligence exhaust from your products, right? Those may be mostly aggregated, not real time, because those are supposed to be used for business intelligence and capacity scaling purposes as well. Now, what is offered by Opensearch is the rich ecosystem of ingestion, orchestration through data prepper, Opensearch assistants, and the newly evolved agents and tools in their toolkits that enable us to not only scale, not only have it auto run, but to also optimize on performance, resilience, and cost, and do those in an autopilot manner. And we will see some examples of how that can be done. All right. And when do we need to move towards this, and how do we need to move towards this, right? Now is the time to start thinking about self-moderated, autonomous, and tuned cloud-native applications, right? We've always had dependency that, okay, there's going to be a DevOps team, there are going to be tools, there was the concept of operational command center and all of that. So all of this getting morphed into autonomous systems that will be monitoring not only the applications, even what is coming in, as well as what is going out of each of the systems. And it covers a whole spectrum of actors, including all the engineers that are responsible for building, maintaining, and sustaining the applications, as well as folks who are evolving it, and making decisions on products as well, right? So through that, now cloud native platforms are able to integrate through leveraging Opensearch to build AI-driven autopilot systems as well. Typically existing cloud native applications that are there today, right? And again, I've taken the service mesh example because that simplifies the number of components and it scales easily using container ecosystems, be it Kubernetes or otherwise, right? You typically have your application hosted in a container, in a pod, with a sidecar that enables you to proxy and maintain metrics and do various observability aspects as well. Now, these cloud native apps both scale within the region, within a data center, whatever it is, right? And across regions as well, if you think about it, right? You may have data lakes, you may have databases, you may have NoSQL systems, you may have caching systems, and you would also have the observability systems built in within each region. And now, in a globally distributed deployment, across regions as well, we need to have the ability to pass on aggregated information, to pass on anomaly triggers, to pass on data lake information in order to support high availability, disaster recovery, as well as to be able to easily shift traffic in case of contingencies, right? So you see a scenario where there are metrics flowing across the entire ecosystem, right? Now, there have been existing proactive self-healing systems, various frameworks, products, commercial as well as open source frameworks like StackStorm and others that have enabled scripting, having runbooks, building playbooks, and orchestrating them through existing open source components, right? And it helps definitely, and you can do the triggers based on either cost, usage, scale up, scale down depending on the usage during the night. Maybe one region needs lesser capacity, the other region might be in a different time zone and it's ramping up the capacity, right? So those sort of auto scaling options have always been there, but those have been driven through frameworks that have been out of band so far. Now we'll see how this has to actually evolve in the AI-driven autopilot ecosystem, right? So if you think about before and after potential target architectures, right? I've simplified it a lot, removing all confidential items. Any cloud native architecture today has applications, be it MVC, be it NoSQL based. You would have a set of those applications in a service mesh mode. You may also be ingesting certain information or data from third party, your own exhaust, from multiple internal systems through some streamers, right? And bringing all of this together in an observability platform like Opensearch, right? Logs are typical examples, and those will be complemented by alerting systems like Prometheus as well, right? And if somebody is looking at it, you definitely have dashboards. If somebody is going to act based on alerts, you'll either have Prometheus or alerts generated through any of those systems as well. Or you'll also have your own implementation of what needs to get triggered through these, through analysis of these logs. If something has gone wrong, if there is an anomaly, if there is zero traffic instead of 50%, and so forth, right? Those were applications that were custom built, if you will. And these helped identify the right points where failure intervention needs to happen also. And various components of open source have helped us build these things until today. Now, how has this evolved with Opensearch bringing in AI native technologies, what has happened is that we can always have intelligent analysis leveraging the ML algorithms that are readily available to do regular anomaly detection. This is a very simple approach to do an autopilot. You infer the failure, not only say that, the traffic has gone beyond 150% or 175%. That's a threshold-based traffic. But this anomaly detection is slightly different, right? It's going to say, it is anomalous because on this time of day, during this period of the year or month, last year we used to have a certain pattern because it's a particular peak season. And this is far below that. Right? So those type of historical intent-based analysis is also possible. Now, once you infer, you can have rule-based options to do self-healing and introduce either additional load balancers, additional instances, tune the CDN settings, whatever it be, through the entire installation. Right? And it doesn't stop here. You go across regions because you may need to influence one region based on what is happening in another region, right? So this is one level of autopilot, if you think about it, right? Now, how has it evolved? Right? From there to now, Opensearch has introduced flow agents, and most recently, the plan, execute, and reflect agents as well, right? And it needs to be tried out, tuned, before you graduate it into a production environment. But those options are there today. Essentially, all of these agents flow through the tools that are readily available. There are various options, including search tools, including actioning tools for each of the scenarios. And you can build plugins as well, leveraging those examples that are readily available in order to plug them in with your existing runbooks or new runbooks and do the same healing in an auto set mode, right? And that is the key value proposition that has been brought in with 3.0 as well, if you think about it, right? And again, it doesn't stop there. We always used to have alert notification. These can also go into those tools and agents anyways, right? Good. Hope everyone is with me. Moving on. And how can this evolve if you think about it? We saw Opensearch being the central piece there. In this autopilot architecture, it further evolves, right? Opensearch can act as the destination as well, if you think about it. You may have various queries, right, through your chatbot systems, through customer incidents, support requests, RFP queries, variety of queries, right? So the common pattern that is evolving and that enables us to adopt Opensearch much more wider is that of leveraging those orchestrators and combining the responses either from Opensearch, from observability perspective, or various other business intelligence systems also. You can replace that with other systems that enable you to derive business intelligence, transactional intelligence, and so forth, right? So some such examples, if you want to think about it, are Apache Superset, which provides rich business intelligence capabilities, charting, alerting, aggregation for one data source. Similarly, many such open source options also exist in order to do mix and match across multiple business intelligence sources. All right. But the key point here is that you can also bring in external knowledge bases, right? We typically would have examples where, for incidents, we create playbooks and runbooks. We will have user guides. We will have API guides, right? We create Swagger definitions for APIs. We create various documentation, right? Typically to guide users if any of these products are SaaS products as well, right? So all of that knowledge base can also be chunked and orchestrated to be used through Opensearch, right? So within your application, if you're building in a chatbot to enable someone to, if it's a provisioning application, you go and try to provision some information for them to extract something out of that, you can provision a chatbot. Or you open up an API, right? If someone wants to integrate with it. Or if someone wants to do things visually, they provide a picture or a screenshot and say, how do I accomplish this? So all of those aspects can also be plugged in, and we'll see those options as well. Okay? And these well-known agent orchestrators exist today. LangChain is a widely used option in the market, and there are various commercial options as well, using which you can combine and cut across multiple such observability as well as business intelligence tools. All right. So how would a sample flow framework look like if we adopt that autopilot approach, right? So let's start with the conversations. Right? Typically, you get a query, or it could be API or a text query, anything that is coming from a customer, right? Or someone representing an external or an internal customer. Our first intent is to see, hey, is there an anomaly? Is there an issue that needs resolution? Right? That is one point. And second one, nowadays, what is evolving is also that we've always known about bots, we've always known about crawling, we've always known about systems that people use to gain intelligence and provide and extract data out of various applications, right? Some are malicious, some are for the good reasons, information for good. So the first intent would be to decipher whether it's a genuine query or is that an injection intent, right? Does that impact one customer or multiple customers reaching out at the same time, right? So essentially these patterns we have solved as part of cloud native applications, the same patterns we need to solve even when we move to a AI native microservice mesh. Because in order to scale, you need to protect the system as well, right? So that is the first check that will come in. People might be trying to do prompt injections as well, right? To extract more of it. So that is one cross check that needs to happen. And how would that happen? You pass on the contextual retrieval and prompts to Opensearch is one aspect. Second, you may have your own vector embeddings. People complement Opensearch with their own vector database or graph databases where you build knowledge graphs of your system based on your schema, right? And there could be custom prompts as well. Now, those conversations are queried to Opensearch through standard vector queries, neural or conversational or even multimodal queries, right? And the information from which intelligence is drawn out could be, as we discussed, your API guides, user guides, provisioning guides, and so forth. You might have incident tickets, incident reports, knowledge base, knowledge articles, all of those. There could be allied third-party data as well. And you would have previous incident logs, queries, resolutions, commonly seen patterns, and so forth, right? So all of this need to be chunked, embedded, and indexed as well as additional data sources. So these come together along with LLM responses to see whether it is useful, right? If it is useful, you proceed ahead. If it is not useful and there is no resolution, that's potentially a new use case, new scenario that is not found in the trained data, right? So you create incident resolution playbooks or runbooks, typical resolution, and save that out. You adopt the necessary process diligence, make it part of the knowledge base, and permanently add it to your data set as well, right? So it's a virtuous cycle of this flow, right? Although this example is for incidents, you can extend it for various transactional intelligence aspects also, right? So if you have a system that needs to learn from an external interaction, external APIs, and automatically update itself, that is another way to do it, right? So this is one typical sample flow, and there could be various versions of it, but hopefully this provides an outline of how AI native is changing the microservice world, if you think about it, right? Because your applications today, the conversations are flowing through some web applications, right, from chatbot. Same way, when you respond back as well, those contexts and history would be helpful. You need to capture ticket numbers and so forth for audit purposes, compliance, and so forth, right? And Opensearch also has various aspects other than logs and metrics to capture this contextual metadata, right? So if you think about it, you not only see graphs, charts based on the time series data, you would also be able to add textual data like annotations, right? So you add an annotation when you start a maintenance event. You could call it, okay, patch upgrade, for example, right? Or you're upgrading the application to the next version, right? You know it, it's in your ticketing system, but is it part of the observability database, right? So how would you correlate events and the behavior seen? Typically, you break down in a rolling fashion, service, upgrade it, put it back to service, observe for some time, and then do it for all the nodes of a cluster, right, of your application. Same thing in any microservice. You do blue-green deployments or whichever methodology you adopt. Where is that metadata that tells you that this is when you started, this was the scenario, this is how things have evolved, right? So along with data, you also need the metadata so that you can search that more intelligently. Okay, all right. Good. Now, we talked about searching intelligently, right? Now that there are ways to add metadata, there definitely exist a rich set of ways in which you can search, right? We'll probably start with the most complex one, right? Because it's a little bit more interesting in that sense, right? So yes, there are days where you are okay to prompt, learn, okay, give me an alternative, give me the best solution. You add adjectives, give me something that is optimized for CPU and things like that, right? All this prompting is fine if you have the time. But a customer who is impacted hardly has time, right? So the first thing he needs is intervention. The easiest thing he can do is share multimodal data. Take a screenshot. Hey, this is what I'm observing. Oh, it's probably an intermittent issue. Oh no, it's continuing for several hours and things like that, right? So that contextual data with image plus text would force you to choose a multimodal search option, right? And in this scenario, we may all have seen, hey, server error, 5xx, 4xx issues, customers reach out, but it's working well inside. It could be something outside as well. So in those scenarios, probably you would adopt an approach where you will do real user monitoring tools as well to complement your internal tools. So real user monitoring tools, all across the globe, they have sites. They probe every minute. You can configure it, right? Every hour. And they provide you intelligence data in order to mix and match with your own metrics and see what the customer is actually seeing, right? So some examples are Catchpoint, web performance management, 24/7 site, various such probes definitely exist, right? That is the multimodal example. The next one is conversational, right? It definitely helps having a historical context, because after some time, the issue is no more the only issue, right? It has a context. Okay, last week it was like this week it is different. It has reduced, it has increased. So there is always some comparison. Oh, it was faster, it is now slower, right? All of those things play a role. And that's where having some memory-enabled context definitely helps for conversational search. So you'll often, and these are the prompts customers definitely provide when they chat, or they provide questions internally also, right? One example is, the frequency of issue has increased or decreased since last evening, since last week, right? It's better, but sometimes it's not, things of that sort, okay? And that provides valuable information for troubleshooting as well. Moving further to neural, right? It's a little bit more intuitive there. Yes, there is question answering, there is context, but it's a little bit more straightforward. How do you fix this, right? So some context is there, but definitely some deeper understanding is needed to go through all the troubleshooting guides and look at some solution, maybe take the action and see whether it resolved, and then adopt a different approach, all right? Moving a little bit further, you would adopt a semantic approach, because it's no longer lexical, right? It's the intent behind the search when someone is asking something, right? For example, someone might say, oh, I see reduced latency of responses. Right? Maybe there's some background job he's waiting on the right amount of latency or response time, right? So we typically have performance tuning guides for all our products, right? Configuration changes and so forth. Dipping into that requires semantic, right? Vector search, essential recommendation, right? It's plugged in all of this from top to bottom as well. And basic prompts could be like, okay, incident looks similar to when you guys did the last patching or something of that sort, right? So these aspects of, and the rich options provide us a way to play around, see what works for which scenario, and adopt corresponding agents, right? So in an incident scenario, your approach could be slightly different. In a scenario where you have maybe internal customers, maybe you are wanting to improve their developer experience, right? Your development team, your SDIT teams, your DevOps teams, implementation teams, who is facing the customer directly for implementations, right? So there is a different approach that can be taken, okay? Where they're already trained on certain things, but they need the value add, right? That richness to quickly attend to things, rather than only focusing on SLA, oh, we need to respond back in 5 seconds, something of that sort, all right? So these options are available today to try this out, right, in Opensearch. So to dig in a little bit deeper, right, just an example of annotations. I think many of you may be exposed to it, but the key point is, for example, if you take this graph, when that red annotation is a text, you annotate because there is a particular action that you are doing, and maybe in response to that, certain thing happened, right? Before that action, there was almost zero and no spike. Post that action, there is a spike, right? It's all numerical data, but when combined with this textual annotation is when you'll be able to look back and see and say that, oh, this is similar to when you last did this, right? So that time series pointing with text is a valuable tool, right? Same way, if you look at another scenario, post a particular either incident or an action, Maybe there was a brief spike and then things stabilized after that, right? So this is a usual, very useful pattern that you can look back and say, okay, it might look anomalous in the short term, but after some time, it stabilizes, right? So these things we cannot normally describe and have playbooks, right? So that's where annotations help, because you'll be able to look back and say when a similar thing happened, or annotate it now so that next time it happens, it's easy to look it up, right? Clear. And the second aspect of it is also that maybe for a particular scenario, you pair it with the replay mechanism, right? So, and you trigger it using the agent to see how and capture some information based on that, right? Okay, under a normal situation, everything matched, whereas when there was a particular issue, there was one mismatch, just as an example, if you will, right? So this is how it spans out, both observability and taking action as well as happening through the same microservice mesh, if you think about it, okay? All right, and the third complementary aspect, and this is just an example, similar client libraries exist all over, right? These client libraries are used as part of the agent tool sets as well in order to do just-in-time real user monitoring, right? This can be deployed outside as well, given the right connectivity. So that way you combine external information all over the globe through systems like Catchpoint, or you deploy your own probes all across, right? And figure a way, right? Maybe your deployment is in US, but just the customer from Japan who is accessing it is facing a particular problem. So all these permutation combinations definitely exist. And building agents and tool sets for each of these use cases and scenarios with single responsibility is evolving to be the way forward, right? Good. With that, I would like to summarize that this is the time to harness the agentic AI capabilities to enhance transactional intelligence, operational intelligence, as well as business intelligence. All these tool sets exist even today. It becomes easier through Opensearch to piece them together and generate respective transactional, operational, or business intelligence data, or aggregate them, and combining with the agents and tools that are provided, take actions for now and even store them for future. Secondly, definitely need to evaluate and adopt, because that is the key part. There is no cookie cutter solution actually. You try out various options, observe how it behaves during a positive scenario, during a rainy day scenario, and then you tune that, right? Third, if you intend it to be autonomous, right, that point about governance and responsible AI framework needs to be kept in mind, right? Because anything initiated by your system into another system, for whatever reason, even for probes and all of that, will be tracked, right? And if you let it run, there could be cost overruns, there could be aspects of GDPR that you need to be responsible for, right? So that gains key prominence. And that's why we would adopt strategies like creating a digital twin, trying it in your own controlled environment, mimicking the real production system, and enabling these autonomous agents to let it run all through, observe the behavior, and then turn things on either in a blue-green mode or whichever deployment methodology your organization chooses, right? But the key part there is that there are lessons to be learned there, and directly enabling it may not be a good idea. Now, what is this evolving into? Like, we are here, right? we used to have monoliths enabled with simple scripts, automation agents, and so forth. Now we are adopting agentic frameworks. Agentic AI is there, tool sets are there. There also used to be robotic process automation and so forth, right? Now we are here. What is it trending towards, right? It is trending towards Internet of Agents, right? Autonomous agents that work between themselves in a way, in a controlled fashion, in a monitored fashion, right? And there are standards and protocols also evolving towards that. We have heard about Internet of Things. Now it is evolving into Internet of Agents. And that's why it's very, very important to adopt architectural best practices like this single responsibility principle that will enable your agents to be responsible for specific purposes that they have been created for. Got it? So it could be observation, it could be taking a very specific action, or it could be to generate an alert. Very simple. Right? All right. And that's how the agentic microservice mesh is evolving. Right? Instead of just calling them agents, we call it a mesh because a single agent cannot do the entire job that you would need end-to-end. And towards the end, agents allow you to optimize things autonomously on a per customer basis also. Right? It's like someone sitting on behalf of a human and doing all the customizations, tunings needed for a customer and taking care of it. Right? There have been technologies even earlier, but more human-oriented, right? So now it is evolving into autonomous systems. Same way targeting business KPIs per customer and doing intervention for them as well. All right? Good. So to summarize, we have wide flexibility of options when it comes to search, when it comes to agents, as well as when it comes to tools, if you will. Right? And it's in our hands to responsibly adopt them and evolve our systems from being cloud native into AI native to reap the benefits of the evolving technologies. All right. Okay. So with that, I would like to open it up for questions. Yeah. Yes. So that part, if you see, apart from all of this, we have a separate classifier to find out about the intent, right? So this is the regular flow, and that classifier enables you to evaluate the prompt and what is helpful or not. Right? So if you can think of it, it's like an adaptive feedback mechanism in a way, right? That as well flows through as custom prompts and vector embeddings into your Opensearch, right? That is something you can create on your own. And the intention of that is, as an architectural pattern, we've always had feedback loops, right? Otherwise, how will we enrich and make things adaptable, right? So you replace what we used to always have a cache or anything of that sort with an intent classifier, right? That is on your own, whereas the main system or the observability incidents platform runs on Opensearch. So this is a virtuous loop that you build in order to give it or generate the custom prompts that will make the LLM response helpful over a period of time. Yeah. And only that may not be fully useful. It has to flow through this, right? The next time a new run book or playbook is created, it has to flow through, right? So, yeah. Good question. Thanks. Sure. APIs and SDKs? Yes, it is there today. In fact, it's part of, I think that's the one I had here, right? Yes. You will see either flow agents or plan, execute, and reflect agents, right? In 3.0, this is the newest one that has support for the MCP protocol, so you can plug in the latest external LLMs. Flow agent has always been there. I think it was there even in 2.x. Flow agent has always been there. This is the newest one. And there was a limited set of tools. They have added and enhanced the number of tools. Each tool does a single job, right? If you do a web search tool, it'll do just that web search, right? And there's a good rich option there. And for each of these vector search options, there is a tool. If it's missing, I think it can be easily replicated and built in, right? Okay. So, yeah.
Is it beneficial to self-host LLM models which power those agents, given the security concerns?
So, there are benefits of public LLM models and of having your own if you have GDPR related compliance mandates, right? You may not always, it's not possible to train through and get everything through the common crawl, right? Common crawl gives the public context, right? Yes, last night RCB won, right? That's the public context. But during that time, how much was the traffic? That is your private context, if you think about it, right? That may not always be publicly available. So yes, there is a cost involved, and there are various options already built in Opensearch that you can run it inside also, or you host it in Hugging Face, play around with it, and then you make the decision around the same. All right. Thanks a lot, team. I think the time is up. I'll be around if you have any other questions. Thank you very much for being a patient listener. Thank you.